Hey, Marcus Irvin. Today in class, we're doing lab 2. So it's going to be circular motion. I have all my stuff. Follow me. Right here, my full setup. I have my computer, my tape measure, which we're going to do in centimeters. 5 and 40. My fishing line, my washers, and my pipe. So we will set that all up, get it all started, and then I will take some videos of me doing the experiment. And again, this is going to be circular motion. We're going for 15 revolutions. I have to time it, which I still got to figure out. And that's it. Let's go set it up. All right, there you go. So basically, I have to measure. Oh, hold on. I have to measure. Why are you not recording? Okay. I have to measure from here to here. As you can see, probably not. I got to get 15 centimeters. All right. So basically, we have one washer on one side, 4 washers on the other side. The counterweight is supposed to do centrifugal force on the single washer to keep this thing, I'm gonna go smaller so you can see, this thing in rotation, I think. Something like that. So those are spinning, but they're not moving. All right, so basically, we're gonna see how fast the radius affects the rotation. So does it spin faster, slower as we move in and out? We're gonna do 15, 25, and 40 centimeters, or in meters, it's like 0.15, 0.25, and 0.40. And we're going to get 15 rotations in. I'm going to try to time it on my watch because I'm using my phone to record me. And I will gather some information and then put it on the spreadsheet and go from there. So as a recap, if you can see it, we're going to go to 15, for instance. And then that will be the distance that I'm going to try to spin this washer in a circle 15 times. And then we'll go to 25 and then we'll go to 40 and see what the results are. All right, so this might make a difference. I'm not sure, but I went ahead and marked the top of this tape at 15, this one at 25, and then this one at 40. Because I'm not gonna lie to you, when I'm spinning it, I'm not gonna know that angle because I don't have a Sharpie on hand. You figure I would, but I don't. So here's to the best of this. All right, it took me a minute to get here. This is gonna be rough, but here we go. I don't even know where to count it at. One, two, three, four, five, six. I don't even know if that's right because it is spinning too fast for my eyes to keep track. One, two, three, four, five, six, 7, 8, 10, 12. Yeah. We're just gonna say what my watch said, which is like, hold on. Once I can log into my watch. Come on, watch. It said 5.66 seconds. So that is the number I am gonna go with for the first one. All right, now we're doing round 2. .42. I am not sure if it's supposed to be faster or slower. I guess I will have to figure that out with the next part of my lab because right now this is confusing. All right, last one. Reset my watch. Let's get the momentum going here. There it is, right there. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 6.47. I really think that there's a number that's off between the 15 and the 25 because it's 5.66 and then the 25 is 5.42. And technically, if the rotations are slower because it's further away, my middle number should be higher. So I'm going to retest that one again. So after the running experiment a couple times to make sure my numbers are correct, the shortest distance is 5.6. Second distance is 5.95 and then 6.4. So the further it goes away, the slower the rotation is, hence more time. All right, so in the lab, I investigated circular motion by measuring how the radius affected the period of rotation. We tested out different radius, 0.15, 0.25, and 0.40, and we have 15 rotations per radius. My results show that the radius increased, the period of rotation also increased. My measured values were different than the theoretical values, but the overall trend matched what was supposed to happen. The issues I ran into personally was basically my reaction time, looking at my stopwatch, trying to count the washer from spinning, and just tracking it all at once was a lot. Overall, the lab demonstrated how the force keeps an object moving in a circular path, and how changing the radius affects the period of rotation, and that's it, the end.